Hello everyone. Welcome to another webinar promoted by SoftExpert. The webinar will be conducted by Mr. James Kovacevic, a principal instructor at Erudicio, and an experienced professional in industrial maintenance and reliability, having worked for several large companies. I wish you all a great webinar.
So for those of you that I haven't had the opportunity to work with or speak with in the past, my name is James Kovacevic. I am a principal instructor with Erudicio. I've been with Erudicio almost 2.5 years now. Prior to that, I held a wide range of roles within maintenance and reliability. I actually started out as an electrician on the plant floor, did that for a while, had an opportunity to become a maintenance planner. Then while I was doing that, even though you're not supposed to, but take over the storeroom responsibility as well and get that kind of moved into a plant manager or a maintenance manager role. And then I spent time with Diageo. You guys may not be familiar with that name, but you probably recognize their brands: Crown Royal, Smirnoff, Captain Morgan, Guinness, Johnny Walker, to name a few. I spent a lot of time with them traveling across North America, South America, Africa, and Europe, implementing maintenance and reliability best practices across their facilities, and then joined Erudicio. Aside from that, I'm going to do a shameless plug here and plug the Rooted in Reliability podcast. It comes out every Tuesday. You can find that on iTunes, Stitcher, Spotify, and a bunch of other locations for podcasts. On a personal side, I got 3 kids, 2 crazy dogs. Thankfully, my wife was nice enough to take them on a drive to get them out of the house so we could do this with hopefully minimal interruptions. And with that, we'll get started. But before we jump into the content, what I want you guys to do is take a moment, and in the chat feature, I want you to put your one word for reliability. We're going to circle back on this in a minute when we talk about job plans, but in the chat, go ahead and put your one word for reliability. What is reliability to you? All right. Now, what does this picture represent to you? When I look at something like this, a pit crew, I get the feeling of speed, efficiency, precision, professionalism, those types of things. Now, I want you to ask yourself, is that how operations views your maintenance department and program while they're doing work? Do they see everyone out there on task, knowing what to do, organized, being efficient and effective with that downtime? I have the experience of not always being that precise with our maintenance group. We get the line or piece of equipment from the maintenance group from the operations for a period of time to do maintenance. And what normally happens? Well, you get one mechanic working on this piece of equipment, another mechanic working on that piece of equipment, but really not being very efficient with our time. All right. That's one of the challenges we experience within maintenance and reliability, is making sure we're efficient and effective with our time. The other thing you may notice when you look at this is you see a lot of safety going on here. Everyone's got their proper PPE, everything's marked out. And in a lot of organizations, not only is efficiency a major important piece of that organization, so is safety. Now, how do we get this efficiency, this safety, all in one? How do we get to that point? Well, in my experience, that reliability, that safety starts with a good plan. And it goes further when you have great job plans. Now, you're probably wondering, well, how do job plans contribute to both safety and reliability? Well, let's dive into that and discuss how job plans help with safety. So some of you may have seen this graph. This comes from Ron Moore, author of some great books. But what he did is he was able to get a lot of data and a lot of information. And what he was able to determine was that as we do more corrective work orders and reactive work orders, injury rates increase. Now, why do they increase? Well, generally, reactive and corrective work isn't planned to the level that reduces the risk of injury compared with proactive tasks. I want you to think about it, and if you want, go ahead, throw it in the chat for me. But what level of detail are your PM procedures or your standard rebuild instructions compared to your corrective or reactive work job plans or work orders? Normally when I walk into organizations and I take a look, PMs, rebuilds, they're really well defined. They're really well planned. They're calling out safety concerns, potential safety risks. They're doing all those sorts of things. But if we look at reactive work or emergency work and even some corrective work, they don't have that level of detail. Not only that, we're being rushed. As we're doing reactive work, we're being rushed because production is waiting for that equipment. So we know that as we do more proactive work and less corrective and reactive work, we're going to have a safer work environment. The other thing.
So James, sorry, just going to pop in real quick. I think so. A lot of the questions you're asking, people are putting their answers into the questions box and not the chat. So it's not that people are ignoring your requests. They are being chatty and offering answers. You're just not seeing them. So, just to give you an idea for the reliability, what word that it means to people, I was seeing a lot of safety. I was seeing a lot of consistency, teamwork, dependability, and efficiency. So those seem to be kind of the main words I was seeing. So I just thought I'd let you know that.
All right, excellent. Thank you, Maureen. All right, continuing on as well, what we know is that as we increase our PM and PDM work orders, our injury rate decreases. Kind of inversely related to the other one. But what we know there is that as our PMs and PDM work is defined, we generally have very good job plans. They're calling out very specifically risks, hazards. How do we mitigate those risks and hazards? Potentially, what permits do we need? Referencing lockout tagout procedures. It's doing all those great things. So obviously, the more proactive we are, the safer we're going to be. So in order to be proactive, we got to be planning jobs. We got to be planning them to the right level of detail. All right. Now I asked about reliability. What is reliability to you? Well, if, you guys gave some good one-word definitions there: consistency, quality, repeatability, teamwork, safety, all those great things. But if you look it up, these are the definitions: the quality of being trustworthy or performing occasionally or consistently well, the degree to which a result of a measurement, calculation, or specification can be depended on to be accurate. Now, I really want you to think about that second definition there. From a PM perspective, or from a corrective or rebuild perspective, do your work orders and job plans allow your mechanics or electricians or technicians to take a measurement, take it repeatably and consistently, so that if I have mechanic 1 go out and take this measurement now, and I have mechanic 2 go out in 5 minutes and take that same measurement, are they going to get the same results? That's what we need when we're looking from a PM perspective. We also need that same level of rigor when we get to corrective and rebuild procedures. But how do we do that if we don't have good job plans? It's really going to be a struggle. Then we also have some other issues with reliability. Now, most of you recognize these, the failure curves from the Nolan and Heap study, what's taught in RCM and a variety of other learning activities. But what it essentially shows us is that most of our failures are not related to age. Most of them are, in fact, related to infant mortality. Now, what does this have to do with job plans? Well, we know those causes of infant mortality come from a variety of different places: design defects, manufacturing defects. Some of that's out of our control. We can't directly influence that when we're developing job plans. But those next ones we can. Installation defects. How many of you have defined specifications for installing equipment? When you're aligning, rotating equipment, are you checking for soft foot first? Then are you doing your alignment? Are you taking into account thermal growth? Oftentimes I see thermal growth is not thought of, and that's an installation defect, because now as that equipment heats up, it's going to grow. It's going to grow out of alignment tolerance, and we're going to have premature failures. What about commissioning? Do we have a proper commissioning procedure built into our job plans, or a proper way to hand it over to operations or shut it down? Those types of things influence that as well. We have improper routine maintenance. Once again, that consistency in terms of performing an activity or taking a measurement. Lubrication, for example. How consistent are we at applying the right level of lubrication there? Do we have the specifications so we know what we need to, what lube levels we need to apply, or are we relying on pump 3 shots of grease into that bearing? No, that's not very specific or consistent. And then we got workmanship. And I'm not saying that we don't have capable people. There's other pieces that come from workmanship, and we're going to talk about those next. We have human performance factors that influence us. All right, there's a lot of issues that potentially are going on that's going to cause some of those workmanship issues. All right, now a lot of this can be addressed with good job plans. But first, before we dive into that, I want to make sure we understand what these types of errors are. So the first one is really an unintended mistake. So what that really means is the slips here can be thought of actions not carrying out as intended or planned. A great example of that is you fat finger something. You meant to type 9, but you typed 8 instead. All right, that's a slip. Job plans can help minimize some of those. Lapses, and I'm sure many of you have experienced some of these. How many of you have driven to work or driven home from work and not remembered that drive? That's because our mind works on autopilot sometimes, and lapses are those exact things. We skip certain steps, we miss certain actions because our mind is on autopilot. Right? Job plans and a checklist combined with that can eliminate lapses as well. Then we have an intended error or a mistake. Now that is a misapplication of a good rule or application of a bad rule. Once again, that's something we can help mitigate and manage through various techniques, but having good job plans will help minimize those as well. And then lastly, we have violations. Violations, someone knowingly and deliberately commits an error. Procedures and checklists, they're not going to help mitigate or minimize those violations. So those we really can't tackle. But by having good job plans, checklists, we can actually address those top 3, the slips, the lapses, and the mistakes. All right. So what I want you to do is in the chat, how many of you are working to reduce some of these issues currently? Are any of you actually actively working to reduce slips, lapses, mistakes by developing job plans, checklists, those sorts of things? Just go ahead and throw that in.
So feel free to just put those in the question, and then James, I'll just kind of give you some feedback, because I guess the chat, maybe that is not a public thing for everybody because people don't seem to see it. And it's hard for me to know as an organizer, since I can see it, whether that's open to everybody. So anyway, I'm
Perfect.
seeing a lot of people saying they use checklists, that they're using their existing PM optimization projects, that they're working on it. A couple people saying they're not working on it. So you're getting kind of across the board here.
Okay, excellent. It's definitely an opportunity. If we go back to those failure curves, 68% infant mortality, we're leaving a lot on the table. Procedures, job plans, that's one of the ways to tackle those activities. And how much does this give us? What's the benefit? So if we have a written procedure available, so I'm talking a good detailed step-by-step job plan like we're going to learn about next. If we have that, we'll get about a 5% error rate typically. Now, if we combine that with a paper checklist, we can get that down to about a 1% error rate. And then if you use digital checklists, built into the system, that will not allow you to continue unless you do so. We can get that down even further. But even having a written procedure, having a 5% error rate, that is a dramatic reduction in infant mortality based off what I see personally in most organizations. Adding a paper checklist to that, hugely, hugely beneficial. Now, those of you who haven't already, the Checklist Manifesto, it is a great book. I highly encourage you to grab that and read it. It talks about human error, the role of checklists in eliminating human error, and a variety of great things around that. It's actually changed some of the way I think about planning now. It's definitely worth picking up and going through. So how do we actually develop these job plans? What can we do to develop good job plans that allow us consistency, repeatability in our work, allows us to capture knowledge, and all those great things? Well, there's a way to do that, and that's called job mapping. So the way job mapping works is we're going to break down not only projects but jobs into smaller and smaller buckets. So at the very beginning, let's talk about a project. We might have a winter shutdown or a summer shutdown. We're going to do a bunch of maintenance work. Now within that project, we're going to have a whole bunch of different jobs. All right. So in this example, we have to replace the number 2 seal water pump. Right? Simple enough. We got a job, we're going to replace the water pump. Now what we do from a job mapping perspective is we take that job and we break it down into larger tasks. Right? So as you see there, we have example of 1.b, remove old pump. 1.a, for example, may have been lockout tagout. 1.c, install new pump. 1.d, commission new pump, and so on and so forth. We break that larger job into tasks. We're doing this so we can bucket our work and dive deeper into the individual steps needed to perform that task. From there, we're going to go down to the steps, and each one of those tasks are going to be broken down into 4 to 7 steps. Now, if we start exceeding that 7 steps, we're at 10, 20, 30, we might need to look at that and breaking that up into a few more tasks as opposed to one larger task. But these are the very specific activities that we're going to do. Set new pump. If we're removing the old pump, it might be, attach rigging, then lifting, and so on and so forth. We're going to get very, very prescriptive in what we're doing here. Then we have one more step down, which is the instructions, and these are specific to each step, and we'll dive into these in a bit more in a minute. But as we break these down, we want to make sure that we do a couple things. One, we start numbering and lettering the jobs, the tasks, the steps, so we can keep these in sequence. As we build these job maps, and I'm not suggesting you hand these out to your craftspeople, and we'll talk about that in a bit, but we want to keep these organized for ourselves. We also want to keep the descriptions very, very specific. One noun, one adjective, one verb, that type of thing. So what we're going to do is we're going to use sticky notes primarily, and we're going to do this over the course of a whiteboard, a desk, something of that nature. And we're going to break out these jobs as such. So one of the things we also have to be aware of is as we start to map these out, we have our steps here: brake coupling, rig to lift, pick up old pump, that sort of thing. There's certain things we need to be aware of, and we need to make sure that we communicate out to our maintenance technicians, especially from a safety standpoint. And those are warnings and cautions. Now I have to ask, I'm sure all of you are very, very diligent, and you've always read the manual that comes with your power tools. And if you have, you would know the difference between a warning and caution. Now, what a warning and caution is, a warning is really related to personal injury. What can go wrong that can injure the user or someone around in that area? Whereas a caution is more about damaging equipment. So when we're building this job map, we need to create awareness around both those warnings and cautions. So what this may look like is we might put a caution before the step. You see, we're going to rig that equipment to lift. We're going to put a caution in there. Next step contains rigging. Failure to follow all company standards and rigging procedures could result in equipment damage. All right. Now, next step is pick up that pump. That's where we could have an injury. So before that, we're going to map that warning. The next step contains lifting. Failure to follow those lifting procedures could result in severe personal injury. We want to map the warnings and cautions before the step takes place. Reason we do that, we want to create awareness of those before the person executes that step. That's why we map them before. We also color code them. Cautions yellow, warnings red. Creates a visual reminder of, hey, there's a risk of injury here, or there's a risk of equipment damage. So we want to call these out. And these are part of the instructions for each and every step. Next, we're going to move on to constraints and resources. Now, constraints really is what is going to inhibit us from completing this step. Right? Now, this can go a variety of different ways. What's the weight of the pump? Where is the pump located? Do we have access issues? And so on and so forth. While resources are things that we need to do to overcome those constraints. So we always map constraints and impediments to the top of the step. Then we map resources to the bottom of the step. So what does this actually look like for us? Well, rig to lift is our step. A constraint is the weight of that pump. It's 2,500 pounds. I definitely can't pick that up, and I'm sure many of you can't either. So what are the resources we need to overcome this? Well, we might need some cables, some clevises. We may need our rigging standard or procedure so we know how we should properly rig this or what the requirements are for us as an organization. And then if we have to pick up this pump, what are the constraints? Well, it's 50 feet off the ground and it's 75 feet from the closest parking spot. That's a major challenge for us to overcome. So how are we going to do that? We need a 30-ton crane with 100 yards of stick, and we have a lifting procedure again. So here, what we're doing is we're really identifying what are all the issues that we're going to have to overcome while we're doing this work, and what are we going to do to overcome those. This allows the planner to really develop or define the tools, the parts, the equipment, the stuff we need to perform those tasks and steps. Now from there, we get some other notes. All right, so here we got to swap that the side coupling hub. It's an interference fit. That's good to know. That's going to dictate what tools we may need to provide our technicians with to go do this job. So in this example, we might need a hub puller. We might need a torch. We might reference some inspections procedures that we have. That way, everyone's doing it consistently. Now, we may also have some other information we need to pass along. And if we really need someone to take a measurement, make a judgment step, we want to highlight that in gray underneath the step. In this example, if those hub teeth are excessively worn, then we want them to replace it, and we are going to provide that part number. Now, I wouldn't suggest we go ahead and kit that part, but we're going to put it as a reference because they may need it. We also have performance standards that we need to hit. Now, we talked about repeatability and taking measurement or consistency in the execution of work. Well, how do we get consistency if we don't have performance standards built into our job plans? All right. So that's something we definitely need to call out. So for this example, if we're going to install flange bolts, you see we got our resources there. We got a torque wrench, the socket size, that sort of thing. There's special instructions, so there's a special torque pattern that we need to follow, but then we also need our specifications there. All right. So that 85 foot-pounds. Now I suggest we take specifications a little bit further using a 3T approach, and I'll talk about that in a moment. All right. But we need to call out the special instructions or specifications that we need to perform that task. Now, if we map all that out, this is what a job map may look like. We're going to have warnings, cautions, constraints and impediments, performance standards, notes, resources, and a variety of things. All right. This is going to get big, and this may get not so pretty. Here's an example of the larger activity for replacing that pump. All right. So this is what the maintenance planner is doing with sticky notes on a whiteboard or potentially a desk. You don't have to make it look pretty like this on the screen. I created a nice pretty one here for an example. Usually this is sticky notes. You take a picture of it and you use that. This job mapping activity is really for the planner to organize and think through the job from beginning to end. It's really about making sure we don't leave any stones unturned. We identify all the critical things to make sure this job is successful, not just from a safety standpoint, but also from a reliability standpoint. Now, some of you may be looking at this and you may be thinking, you know what, that's a lot of detail. I don't know if I need that level of detail in my job plans. You know, I hire experienced people, or I only hire journeymen. I don't need all that. Well, I challenge you to go ask 3 or 4 or 5 of your journeymen on how to perform a task if you don't have procedures like this already. And I'm willing to bet you're going to get 3 or 4 different answers. They may be similar, but they're going to be different. And when they're different from a preventative or predictive standpoint, can we trust our reading to be consistent? You're all well aware that from a predictive maintenance standpoint, we need our readings to be consistent and repeatable. If we don't have that consistent, repeatable readings, that data is a potential issue for us. We may not be able to trust it. So you need to get that level of detail to make sure we get that from a predictive or preventative standpoint. From a corrective standpoint, if we put this pump in and we went to start it up and it failed upon startup, if we don't have a good job plan like this, how do we go back and figure out where things went wrong? How do we know where the mistake was made or where the issue occurred? It's going to be very, very difficult because everyone does it differently. What we can use these for is as we develop more of these and get to this level of detail, we can start figuring out where the errors occur, where the issues occur, and put in checks. I was working with a client in Illinois, October, November of last year, and what they'd had for certain parts of their job or certain jobs, they actually had what they called QC checks built into their job plans. So in this example here, after we align the shafts down there at 1C4, they would actually have another step in their procedure right after that, which would be QC check. And if it was alignment, it meant they had to take a screenshot of the as found and as left readings of that alignment so they could prove that they hit the specifications required. Now, if they couldn't take a screenshot or something like that, there were times where a lead hand or a maintenance supervisor would actually have to come over and verify that those specifications were hit. They were doing that because they knew there was opportunity for errors within these job plans, and they experienced it over and over. So they built those checks in to make sure that those didn't hit the shop floor. That's how another way we improve reliability through job plans. Now, I know what you're thinking. Do I give this to our technicians on the floor? The answer is no. This is a tool for the planner to develop the job plans, but this is not what we're going to hand out to the technicians on the floor. The planners have to use their technical writing expertise and their communication skills to assemble this into a job plan next. All right. But before we go there, I want to touch on one more thing here from a detail standpoint. All right. As I mentioned, many of you probably think that this is too much detail. Some of you are thinking this is the right level of detail. Now, one of the things you got to consider when you write job plans is that level of detail that's required. All right. Now, one of the ways to do that is, what is the current skill level within your work group or within your team? If everyone's very, very experienced and so on and so forth, then we might not have to put as much detail. But I caution you if you're thinking that way. You're not always going to have that experienced workforce. You're not always going to have those very experienced mechanics. You may have apprentices coming in, junior people coming in. So we want to write job plans not just to the current level of experience, but also the future level of experience. Right? That's important. As people retire and move on, if we're writing them to this level, we're capturing their knowledge. They're helping us update these to the right level. So as new people come in, we don't have to relearn all this stuff the hard way either. All right. From there, once we have this, we're going to convert that to the job plan. All right. Now, how we do that is with something called Simplified Technical English. All right. So Simplified Technical English is really a set of writing rules, and it actually came out of aviation. For those that are not that familiar with aviation, the international language of aviation is English, meaning every control tower around the globe should have some English-speaking people to be able to communicate with aircraft. Most manuals are all provided in English as well. Well, some of the challenges with that is English isn't always everyone's first language. It might be their second or third. So Simplified Technical English is a way to communicate in a way that is understandable for everyone, even if English isn't their primary language. It also eliminates some issues with how we interpret things. All right. So writing procedures is not a simple task. All right. Many people have different opinions on the sequence, the specifications, etc. But we really need to rely on Simplified Technical English to help us. If we like to write novels when two sentences will work, that's going to cause issues from a reliability standpoint. Maybe misinterpretation, miscommunication. We might be doing things ahead of where we should be. Think back to some of those psychological factors we discussed earlier. Good procedures help us eliminate some of those. So Simplified Technical English, it's a set of writing rules, how we're going to write, and we'll cover those in a moment. There's a dictionary of controlled words, all right? Slang, specific words mean certain things, that type of thing. One word, one meaning, right? And the idea behind this is to reduce that ambiguity, improve clarity, comprehension, and consistency in the work. Now I'm going to share with you an example of why this is actually helpful. I had the opportunity to work with a client down in California. They had a seasonal workforce, so it was in agriculture, and they would have a lot of non-native English speaking people come on site and do some of the maintenance work as well as the operations work at certain times of the year. Well, there was an activity that was being performed. It was a simple oil change, right? And within that procedure, it said drain the oil, replace the filter, fill oil, check for oil pressure, that type of stuff. Well, interestingly enough, when we got to the replace filter portion, what do you think they did? Do you think they took the old filter off and installed the new filter? That's what I would assume they did. But not being a native English speaker, English as a second or third language, to them replace meant you take the old one off and then you put the old one back on. It sounds silly, but it happens. So we need to be very specific in how we deal with writing procedures. Once again, you're going to vary this based upon your organization, but it is something we need to be aware of. So from a simplified technical English standpoint, we want to be very specific and we want to keep it simple. There's whole courses and plugins and stuff you can get for this. I advocate keeping it simple. We want to use very short sentences. I don't want any big run-on sentences or anything like that. If we're writing a paragraph, less than 6 sentences. No slang or jargon. So I was working with a mining client down in the southern US, and they had a lot of bucket conveyors. And every person you asked had a different name for those buckets. I had buckets, diggers, dippers, bins, just to name a few. Everyone had their own slang for that particular part. We had to standardize that to buckets, both in the CMMS as well as the procedure, so everyone knew exactly what was meant. Right? We want to be as specific as possible. You always want to use a or an and the where possible, all right, before a particular object. When you do sequential steps, you want to break them out separate lines. I often see people, what they'll do is they'll put a colon or semicolon and they'll do 1, then 2, then 3, all in this big run-on sentence. Break out sequential steps as separate sentences and lines. Make it easy to follow. If you're going to do lists, put a dash in there, a bullet, but break them out that way. Graphics are another one of those areas where they're over and underused. I've seen organizations go to a completely visual work instruction. It can be helpful at times, but it can also hinder at times. And I've seen others where they don't use any graphics. There's got to be a balance there when graphics are required. When they can provide clarity, maybe an exploded view, or if you have to take a measurement in a very specific spot, but there's no consistent way to ensure someone is through text, put a picture in for that, absolutely. But I wouldn't advocate having a complete visual work instruction, if you will. Warnings, cautions. Talked about those already, but we want to call those out in bold letters before the step is occurring. All right, that's going to draw attention to that potential risk and make sure that everyone is aware of what it is. Some other stuff. I mentioned the 3T methodology for identifying performance. And to me, this is a very simple way to make sure everyone's hitting consistent measurements and performance requirements. So the 3T methodology, the first is target. What is the target that they're expected to achieve for that work? So in this example, our target is 35 foot-pounds. Then we're going to provide that tolerance. So plus or minus 10%, or plus 10% minus 0%. Whatever that tolerance is, we want to specify that out. And I like to go the one extra step of not just saying that plus or minus, but also give them the range that is acceptable in whatever value is that they're measuring. This eliminates that one other possible error or mistake that can come in from misplacing a decimal or converting units or whatever may take place. Then we have the test. And this is really verifying the as left condition. So in this example, what I may do, take a torque wrench, set it, see where, and figure out what the actual torque is on that value. If we're doing alignment, right, that target may change on shaft to shaft alignment, depending on what that rotating speed is. If it's 1800 or 3600 RPM, we're going to have different tolerances. So we need to make sure it is specific to that particular application. And once again, we'll put those different tolerances in there, and then we'll have them record as a way to validate that we are in fact inspect. Sorry. Right. Now, as we pull all this together, now we can combine this into a good job plan. What that job plan looks like is something like this. Now, I know many of you are using SAP or Maximo or other systems, and you can't always set up the color coding. I get that. If you can set up color coding within your CMS for warnings and cautions and performance specs in green, do so. If you can't, just put a big, bold warning or caution, or capitalize it all like you see in the example here, but do something to call out attention to it before that step takes place. Now here you can see as we break it down, replace the pump component of the number 2 seal water pump. Once again, that's our job. That's that number 1 level. Then you see we got our task broken out. That's indented in 1 step, the 1A, 1B, 1C. Then we bring it in 1 more level to those steps. So disassemble the coupling, remove the flange bolts, and so on and so forth. We're going to bring it all in there. Now, one of the major advantages to this approach, actually there's a few. First of them is we often get asked, how do we get good time estimates for our jobs? When you break jobs down to the individual steps just like this, it's very easy to come up with accurate time estimates. Instead of taking a swag at it, by breaking it down step by step, you get a very good idea of what the time to take to do this job is. All right. The other major advantage to this approach, where we take the time to build those job maps, then convert it to this job plan, is that even if it's a job we've never done or unfamiliar with, when we break it down in that logical way, we can think through most of the things that are going to come up. We can think through and identify what tools, what parts, what equipment we're going to need. And oftentimes, if it's a larger job, complex job, it may not be just the planner doing this. It may be the planner and 2 or 3 very experienced maintenance technicians that are building this job map together, and then the planner will convert it to the job plan. The whole goal here is to really make sure that we identify everything we need to do to eliminate some of the risk and some of the wastes from the maintenance process. So risk being the safety and reliability side of things. From a waste side, the efficiency. How many times do we walk back and forth to the storeroom? How much time do our maintenance guys spend looking for materials or information or those types of things? When we break it down to this level, we can make a significant difference and reduce the amount of time it takes and ensure that job is done well. Now, in the question box, if you can go ahead and answer, how many of you have job plans that are written to this level? And if you do have some that are written to this level of detail, what percentage of your work actually sent out to the technicians in the field actually have that level of detail?
All right, so I'm seeing a lot of none, not even close, 1%, we don't, nope, don't have it, trying. I got a 5%.
All right.
There you go. 3%. Oh, someone is at 70%, so that's good.
That's very good.
Working on it, 30%. So, I think I just saw an 80%. So sorry, 70%er. Now we got a new winner.
All right,
but,
excellent.
Yeah.
Excellent. So, it takes a lot to get to this level. So how do we go ahead and make that change? How do we transition to that level of detail in our job plans? Now, I am not advocating you start planning every single job to that level at this point. I don't think it's going to work. I'm a big proponent of pick 2 jobs a week and plan them to that level of detail. That's it. Pick 2, break them down to that level, get that level of information in there. The ones you pick, I think, are very important. If you only have time to do 1 a week or 2 a week, that's fine. Pick ones that you're going to be able to leverage that success from. So I want to see PMs that we're doing on a weekly basis. Those ones are good candidates for this job mapping activity right off the bat. complex rebuilds. When we rebuild something and we know it fails 10 or 20% of the time after we rebuild it, good candidate for this activity. Corrective jobs or rebuilds that we do quite often, once again, another good candidate. Or if you have a specific model of a pump spread all across your facility, work on that pump is probably a good idea because you develop it for one, you develop it for the rest of the facility. All right, that is the big thing here with these, is we want to make sure that if we take the time to develop these job plans, write them, get them down to that level of detail, we want to make sure that we're going to get value for it. So pick ones that we're doing often, that result in a lot of downtime, that are complex and people confuse or mess up. We really want to focus on those. Now I'm saying 1 or 2 a week as a good starting point. Obviously, you're going to hit that tipping point that as you have more of these in the system in your job plan library, you're going to free up more and more time to develop more and more. But as a starting point, 1 or 2 a week is a good way to do it. Now, the other challenge with some of this is when you traditionally haven't had good details in your job plans and you're sending them out to the maintenance guys for the first time. They've become accustomed to not getting good job plans. So do you think they're going to take the time to read that work order? I'm guessing the answer is no. They're probably not going to take the time to read that work order because they're used to getting these very vague, undescriptive job plans. So one of the ways you can actually overcome some of that and work to create awareness or draw attention to it is if you print your work orders, the ones that have a really good job plan like we just looked at, print them on pink or green or orange paper. Print them on something other than white. So it acts as a visual cue that, hey, this one is planned to the level of detail. Maybe I should read it. All right, that's one way. The other challenge we have with these is even if we use the job mapping approach, the planner is not going to develop a perfect job plan. I'm sorry, I have yet to see it. And if we're developing perfect job plans, we're spending too much time because perfection is the enemy of good, and we're not going to get anywhere if we're aiming for that perfection every time. So what we need to be doing is using feedback from our technicians. So once again, if we have that colored paper, people are reading those. If people see something wrong, you got the wrong specs, you missed a step. Hey, if you do this way, it's going to save us 10 minutes because of this. We want that feedback and we want to incorporate that into the job plan. All right. The key to that though is making sure that we actually use that feedback. Nothing's worse than asking for all this feedback and then all these job plan changes sitting on a planner's desk accumulating, because after 2 or 3 times of seeing that same issue and reporting it, you're going to lose that feedback, and that is very hard to get back. One of the ways I've seen some organizations overcome some of this is if you're not getting any feedback is supervisor may be saying thank you. That's one way. More elaborate, I've seen where names are entered into a raffle for people who provide good feedback, and once a month the gift card goes out, or a pizza lunch or whatever. We can do stuff like that as well to get this feedback. The idea is to build these up over time based on experience, so that way everyone can do this job consistently and well over time. Right? Is if you're interested, feel free to reach out to me. My contact information is on the screen. I got a white paper on this topic. I'll be more than happy to provide to you. Just reach out and I will get that to you. It walks through this step-by-step detail. It gives you a little bit more information on some of the technical writing aspects. And, that is a big win for you guys to start using this moving forward. In addition, as part of that Eruditio helps as well, if you want to use this methodology and write 1 or 2 job plans, or you want to submit a job plan for some feedback and coaching, let us take a look at it, that type of thing, you can send it to me directly. Contact information is on the screen, and I'll be more than happy to review that, provide you some feedback, or get on a call with you and walk through what I'm seeing, what opportunities I think there are. So that's there for you guys. Reach out if you need it.
On behalf of SoftExpert, thank you for the presence of everyone who participated in this event. If you have any questions, please contact the presenter via email. To see other webinars, ebooks, and white papers on this subject, please visit our website at www.softexpert.com. Find out more about SoftExpert solutions for enterprise business processes improvement, automation, corporate governance, excellence, and compliance management. Thanks for listening. See you next time.